Hello and welcome to World of Warbirds. I'm Brian Pierce. Please sign up at my Patreon to get episodes earlier, bonuses, to have a say on future content, and to interact with me and other Warbirders directly. But mainly you'll have the satisfaction of helping keep this podcast going. You can also toss me a tip via PayPal at WOWB17, or even just drop me a review. Thank you for your support. Now on to the show. Hello, Warbirders. Isn't it weird that we're about 5 years into this podcast, and I'm finally only getting around to the Ju88 now? I've always been interested in this bird, and it was one of the very first models that I made as a kid. Like the North American B-25 Mitchell or the de Havilland Mosquito, I find it fascinating that it did so many roles for so long, and it was never really properly replaced. Well, now I've just purchased a new model kit and figured it was a great time to get reacquainted with the 88 and bring you guys along with me. The model may take some time. It's early summer in North America, and that means a lot of gardening and yard work, and hopefully some cycling and hiking too. But I promise that I will do my very best to keep up with my World of Warbirds release schedule. Okay, so way too much preamble, let's dive in. So if you want the story of Hugo Junkers, check out my Ju52 episode where I tell his complete story. But the Ju88 begins with an idea. The idea is that if a bomber is fast enough, it won't need defensive armament or even escort. It will just outrun anything that is sent up against it. This concept was called Schnellbomber, which just means fast bomber, and this concept was supported in Germany literally from the top on down. Now, when they embarked on this plan, they set up sort of an arms race where a Schnellbomber would be developed that could outrun the existing fighters, but then the fighters would catch up and they'd have to start all over. The first Schnellbomber was the single-engine Heinkel HE-70, which was replaced by the twin-engine Dornier Do-17. By the time of the Spanish Civil War, it already showed that the Do-17, when fully loaded, wasn't fast enough to escape interception. Luckily enough, back in 1934, the Reich Luftfahrtministerium, RLM, had issued a requirement for the next generation of Schnellbomber. The new aircraft was to be able to maintain a speed of 500 kilometers per hour, that's 313 miles per hour, for 30 minutes, and carry one defensive machine gun and 500 to 800 kilograms, that's 1,100 to 1,760 pounds of bombs. The crew was to consist of a pilot, a bombardier navigator, and a gunner. 3 companies stepped up: Junkers, Henschel, and Messerschmitt. Henschel's 127 honestly looked like a smaller HE-111, but with big mouth air scoops on the engines. Messerschmitt took a shortcut by modifying a Bf-110 with a glazed nose to accommodate a bombardier and called it the Bf-162. Several prototypes of each were made and flown for the competition. Over at Junkers, they went all in. Not only were they going to design one new Schnellbomber, they were going to design 2. 2 studies within the company had generated twin sister aircraft concepts. Junkers' chief designer Ernst Zindel, along with his team, which interestingly enough also included an American engineer, Alfred Gassner, decided not to put all their eggs in one basket, but to develop both and see which one was best. They were pretty similar. There was about 90% parts commonality, and the main difference was that the Ju88 was to have a single vertical tail fin, while the Ju85 was planned to have twin vertical tail fins and rudders. The Ju85 design was actually the favored one because of the perceived better rearward defensive armament. On a standard single-fin aircraft, a rear gunner firing straight back has a massive blind spot, the tail fin itself. By splitting the tail into a twin-fin configuration, similar to what you see on a Dornier Do-17 or Messerschmitt Bf-110, The center of the rear view is completely wide open. Junkers built a full-scale mock-up called the Ju88A. I found a picture of it and we'll post it on the Patreon page. For those who can't look right now, yes, it looks like a Ju88, but with twin tails. So the RLM had options. In the end, they chose Junkers, and of the two Junkers sisters, they chose the 88. A single central tail fin, the Ju88 setup, has significantly less structural weight and aerodynamic drag than a twin tail setup. Since the whole point of the Schnellbomber was raw, unadulterated speed, the Ju88 won the math war in that regard. There was another reason why the single fin would be best, and that's the dive bomber obsession. Now, by calling it that makes it sound stupid, but it's all about the problem of actually hitting something with your bomb. In the UK and the US, the focus was placed more on developing more accurate level bomb sights and using large numbers of heavies to saturate the target. The RLM became very enamored of using small numbers of much more accurate dive bombers and using the whole plane as a bomb aiming device, and not wasting resources on huge numbers of bombs carried by huge numbers of bombers in large formations. It actually makes sense for a country with limited resources trying to win quickly. So it doesn't seem so misguided now, right? In fact, as I think of it, it's kind of the 1930s and 1940s version of precision smart weapons. And to make it even more precise, the Luftwaffe had a very fancy bomb sight that I'm going to tell you about later. But it was difficult to accomplish a dive bombing attack with large aircraft, and it forced designers to have to make the Junkers plane to be strong enough in a dive. Twin tails were notoriously prone to twisting or fluttering under extreme G-forces. In fact, an early twin-tailed Ju-87 Stuka prototype had actually broken apart and crashed during dive testing for exactly this reason. So the twin-tailed Ju-85 was DOA, and the single-tailed 88 got the job. On the 21st of December 1936, the prototype Ju-88 version 1 took to the air and reached a speed of about 580 kilometers per hour. That's 360 miles per hour. The Luftwaffe was very happy. So up to now, the story has been about different options getting winnowed away to decide on a single, successful Schnellbomber. Now here's where things start to diverge. Because if you think about it, if you really want your Schnellbomber to be, Schnell or fast, you have to fully commit to that. Fully. Because as soon as you start adding draggy features or guns or crew, you are compromising the whole Schnell thing. The requirement to dive bomb already did that. The 8th and 9th prototypes had strengthened wings, added dive brakes, and a longer fuselage. A dive control system was also added that would automatically move the elevators to their full-up position to bring the aircraft out of its dive and into a climb following the release of the bombs. They also added another crewman, which made 4. All of this added weight and took away the Schnell. Does everyone know what the 88 looked like? Overall, it was a twin-engine medium bomber with a cockpit that was slightly higher than the fuselage. It was a tail dragger, single tail, right, with the main landing gear featuring twin oleo struts that retracted into the engine nacelles by twisting the new single-leg main gear strut through 90 degrees during the retraction sequence. For shock absorbing, the 88 used stacks of conical Belleville washers. Now I just learned what these are and how they're used, so I want to tell you. They are metal washers, which are usually flat and round with a hole in the middle. Belleville washers look more like a shallow cone, and if you stack them, they compress and act like very reliable springs. They served as the main form of suspension for takeoffs and landings. So the engines will fool you. They appeared to be air-cooled radials, but they aren't. Inside each nacelle was a Junkers UMO 211, which was a V12 liquid-cooled inverted piston engine generating about 1,300 horsepower at takeoff. Between the engine and the three-bladed prop, though, there were annular, meaning ring-shaped, segmented oil and coolant radiators, which made them look like radials. The nose was extensively glazed with flat glass panels, which were called a beetle's eye. It was also fitted with cable-cutting equipment as a defense against British barrage balloons, which proved to be highly effective. As I said earlier, the Luftwaffe loved it and wanted as many as possible. They were promised 300 per month in 1938, but all the changes made that impossible, and when the war broke out, there were actually only 12 in service. Are you enjoying the show? Please help support it at World of Warbird's Patreon. It's only $5 a month. There's advantages. You'll get your episodes a week earlier, and you'll get bonus episodes. You'll have say on future content, and you'll be able to interact with me directly. If you are presently listening to this through Patreon, well then thank you for your support. You can also toss me a tip via PayPal at World of Warbirds B17 at WOWB17. You can give me a good review or share me with a friend. It all helps, and I appreciate it more than you know. So there were only 12 available at the start of the war, and those were used in experimental testing and were involved in operations in Poland and on raids against the Royal Navy. They didn't accomplish much to start. Kampfgeschwader 30 fought in the Battle of Norway and engaged Allied shipping as its main target. On the 9th of April 1940, Ju88s of KG-30 dive-bombed the battleship HMS Rodney, damaging it and sinking the destroyer HMS Gurkha. They did lose 4 Ju88s though. More than 100 Ju88s were involved in the Battle of France. These suffered high combat losses and also quite high accident rates due to the demands of flying this high-performance new plane. It reminds me of the story of the B-26 Marauder, where some crews were reported to be more scared of their own aircraft than of the enemy. In the case of the 88, some crews were even requesting transfers to HE-111 units. The 88 crews were forced into a quick withdrawal from action for supplemental training to get them used to their new, fast mounts. The Ju88 had a tough time of it in the Battle of Britain too. Many losses were due to training accidents or crashes or malfunctions as they worked in the new type. Also, its speed didn't seem to be protecting it, as it suffered similar loss rates as its DO-17 and HE-111 sisters. And Ju-88 losses over Britain totaled 303 aircraft. To try to stave off losses, the single MG-15 rear machine gun was swapped for a twin-barreled MG-81Z machine gun, and additional cockpit armor was fitted. Before leaving the Battle of Britain, I need to take you on a little detour about one tiny, yet very important sub-battle of that campaign, known as the Battle of Graveny Marsh. And it was a battle of ground forces. Well, kinda. In September 1940, a Ju-88A1, nicknamed Uhl, the Owl, by its crew, had lost one of its engines due to anti-aircraft fire during a raid on London, and RAF Spitfires from 66 and 92 Squadron had then attacked the wounded Ju-88 over Faversham, knocking out its remaining engine. Now with no engines, the pilot Unteroffizier Fritz Ruland made a crash landing on a coastal mudflat called Graveny Marsh in Kent. The entire crew survived the crash. A local British infantry detachment, the London Irish Rifles rushed to the mudflats to capture the plane and the crew. Imagine their surprise when they got close to the plane and heard machine gun fire. So the British infantry did what the infantry does, and they returned fire, and one of the Germans was hit in the foot. The crew then surrendered and were taken prisoner, but not before warning the Brits that one part of their aircraft might explode at any moment. Thankful for that knowledge, the Tommies took the Jerrys to the Sportsman Inn for pints. Very sporting, that. There's a plaque at the Sportsman Inn commemorating the battle, and if I ever get around to organizing the World of Warbirds travel tour to visit the famous World War II aviation sites of Europe, I think we'll have to stop at the Sportsman Inn for pints. What do you think, Warbirders? Okay, so there was more going on during the so-called Battle of Gravity Marsh than meets the eye. First thing, it wasn't really a battle, as there's no evidence that the German crew was actually shooting at the Tommies. They were shooting at their own plane. What? Why? They were trying to destroy the bomb site. You see, the Owl was a brand new plane with a brand new, highly advanced prototype dive-bombing site that the Allies had never seen before. It was so advanced that it had an early version of what we now call a HUD, or heads-up display. The site was called the BZA Stuvi system. The German crew certainly knew the value of the prototype system in the cockpit, and had immediately tried to set off the internal demolition charges to obliterate it. But the Tommies had arrived before the charges had blown, so the crew had tried to blast it with the plane's machine guns and the survival kit submachine gun, setting off the so-called infantry shootout. The warning that the aircrew gave to the Brits allowed Infantry Captain John Cantifer to rush into the plane, locate the mysterious black box, and throw it into a drainage ditch to save it from the onboard explosives, an act that earned him the George Medal. The intact BZA Stuvi system was secretly given to British scientists to get their first very deep look into the automated genius of German dive bombing technology. Prior to this system, dive bombing was pretty much what it sounds like. Dive the entire plane at the target and pickle your bomb. The problem was that the early Ju88 crews were forced to dive at terrifyingly steep, near vertical angles to ensure accurate bomb hits, overstressing the airframes and, yes, the crews. The solution was the new bomb sight, which allowed pilots to execute highly accurate dive bombing attacks at more shallow angles like 30 degrees or less. Because the computer automatically calculated the drift and release point during the shallow dive, pilots no longer had to dive vertically to match the target. The BZA, Bombensiegelanlage, was an advanced analog computer system designed to continuously calculate the bomb's precise impact point based on speed, altitude, wind, and dive angle. It was primarily manufactured using components from Busch and Jaeger and Siemens. The Stuvi was short for Sturzvisor. It was an optical reflex bomb sight, HUD, through which the computed targeted data, the pipper, was dynamically projected for the pilot. The optical and glass elements were designed by Carl Zeiss. The level bomb sights that we're used to thinking about, like the famous American Norden, required a long, flat, straight bomb run. The BZA was the exact opposite. It was built entirely for dynamic, high-stress, violent drops. Physically, the BZA was a sealed, rugged metal box packed with an intricate web of gears, cams, electrical synchros, and a gyroscopic stabilizer unit. Instead of relying on guesswork, the BZA was hardwired directly into the aircraft's primary instruments. It constantly ingested real-time mechanical data, including barometric altitude, airspeed, and the exact angle of the aircraft's pitch, fed directly from the gyro. Before entering the attack, the navigator or pilot would dial in a few environmental baselines: wind speed, wind direction, the target's estimated altitude above sea level, and atmospheric pressure. The BZA translated its mathematical calculations into a visual overlay projected onto the Stuvie reflector sight, mounted right at the pilot's eye level. As the Ju-88 entered its steep dive, the BZA computer continuously crunched the physics of a falling bomb. It would automatically drive a mechanical linkage inside the Stuvie sight, physically moving the illuminated aiming reticle up and down across the glass screen. The pilot's only job was to fly the aircraft so that the moving reticle stayed locked dead center over the target. If the dive steepened, the reticle shifted. If the plane accelerated, the reticle adjusted. Even more amazing, the BZA just didn't tell you where to aim, it took over the flight controls to save the crew's lives. When the Ju-88 plunged in a dive-bombing attack, the G-forces during a manual pullout could easily exceed 4 or 5 Gs. This caused immediate pilot tunnel vision or a total blackout, leading to fatal crashes. So the BZA would recover for the pilot. At the point of bomb release, the pilot lined up the Stuvie reticle over the target and pressed the bomb release button on the control column. The moment the button was pressed, an electrical relay activated the automatic dive recovery system. The system retrimmed the elevator tabs and pulled the control column back manually, executing a smooth, structurally safe, automated pullout that leveled the aircraft out into flat flight, even if the pilot was temporarily grayed out from the G-forces. So initially the British government hushed up the entire Gravity Marsh incident in the newspapers. They wanted to thoroughly examine and reverse engineer this amazing system without letting the German High Command know that their highly classified, automated targeting secrets had been compromised. Let's get back to operational history. Ju-88s were involved in the invasions of the Balkans and Greece, and were used before Barbarossa in mapping the western part of the USSR. In the opening days of Barbarossa, Ju-88s achieved great success against Soviet air bases and were used for night raids over Moscow. Although these were not sustainable due to other demands, and later were whittled down just to nuisance raids of under 10 aircraft per night. Due to a shortage of Stukas, the Ju-88 were brought in to help in the direct ground support role. Understandably, they incurred severe losses from ground fire. Although they suffered there, the Ju-88 was beginning to show itself to be a real Swiss Army knife, able to do many different roles. It began to excel in anti-shipping, either in dropping torpedoes or by dive bombing. It was used against the Soviet fleet, Arctic convoys, and in the Med. On the 2nd of December 1943, 105 Ju-88s achieved amazing success when they attacked the Allied-held port of Bari, Italy. They were armed with bombs and motobomba, which were Italian circling torpedoes. They sank over 20 Allied ships, including the U.S. Liberty ship John Harvey. This is a particularly interesting side story because until today, I didn't know that poison gases were in the combat theater. I mean, I always guessed that they were present, but hadn't heard any examples. Well, the John Harvey was filled with 2,000 M47A1 mustard gas bombs, each of which held 60 to 70 pounds of sulfur mustard. When the ship was attacked, the gas escaped, and 628 military victims were hospitalized with mustard gas symptoms. And by the end of the month, 83 of them had died. The number of civilian casualties was thought to have been even greater. So, now we know. When we start talking about versatility, we should talk about variants. As with many Swiss Army knife-type airplanes, there were a zillion subvariants. But to keep it sane, I'm going to focus on the main A through G models. So the A model was the main bomber variant, and even within that there were 17 subtypes. I'll just touch on a few of the more interesting ones. Of the 15,000 to 16,000 total Ju-88s built, about 9,000 were A models. The Ju-88A3 was a conversion trainer. Remember, the Ju-88 was considered a hot machine, and pilots needed some help in converting to it from easier types. It had dual controls and throttles, and various instruments were duplicated. The A4 had a longer wingspan due to its redesigned wingtips. From field experience, the undercarriage was reinforced, and provision for 4 external bomb racks was added. The A11 was the factory-built tropical version for use in the North African desert and the Mediterranean theater. These would be officially designated with the suffix trop. So what changes were made in order to allow the Ju-88 to shift from the cool grey skies of the Battle of Britain and plunge into the blinding heat and choking dust of the desert? The primary enemy of any aircraft engine in North Africa wasn't enemy fighters, it was the sand. The fine, razor-sharp desert silt would get sucked into the superchargers and cylinders, acting like sandpaper and destroying an engine in a matter of hours. So, how did they protect the engines? Mechanical sand filters were heavy, boxy air filters over the supercharger air intakes on the sides of the engine nacelles. These filters contained fine wire mesh and oil bath systems to catch the dust before it reached the big Jumo V12s. The cooling systems, both oil coolers and coolant radiators, had to be modified to cope with ambient runway temperatures that regularly exceeded 40 centigrade, that's 104 Fahrenheit. Dust wasn't just a problem on the engines. Fine dust would destroy hydraulic seals and landing gear struts. The trop versions used specialized rubber boots and scrapers to keep the grit out of the moving hydraulic parts. Now, these trop systems didn't come without aerodynamic penalty in several ways. The filters caused massive parasite drag and disrupted the clean airflow over the engine nacelles. A Ju-88 A4 trop lost roughly 15 to 20 kilometers per hour, or 10 to 12 miles per hour, of its top speed just from having the filters bolted on. Furthermore, because the air filters restricted the volume of air entering the supercharger, the engines couldn't breathe as deeply, which slightly reduced their maximum power output at high altitudes. Desert pilots had to accept that their Schnell bomber was a little less Schnell than its European sisters. While Junkers produced trop models straight off the assembly line, the chaotic reality of the Mediterranean theater meant that standard non-tropicalized Ju-88s were constantly being rushed to North Africa as emergency replacements. Frontline mechanics had to frantically install trop field modification kits in open-air desert hangars while overspraying green with tan paint. The Ju-88A13 was a low-level assault version with the dive brakes and bomb sight removed, and additional armor was added for the crew, engines, and fuel tanks. This 88 was upgunned with up to 16 MG-17 machine guns housed in gun pods. The Ju-88A-17 was built as a dedicated torpedo bomber with no ventral gondola. One torpedo rack under each wing replaced the 2 bomb racks. A long housing on the starboard side of the nose contained the torpedo aiming mechanisms. Okay, so now I've mentioned the G word, gondola. Yes, the word originates from the curved flat bottom boat with the guy and the pole and the singing. In airships, they use the word to describe the curved flat bottom control pod underneath the ship. So when aircraft engineers started adding a curved pod underneath planes, they called it that too. Actually, the Germans officially called it the Bodenlaufett, meaning bottom mount, which was shortened to BOLA. The crews affectionately, or actually miserably, called it the Bodenwanne, bottom tub. It's on some Ju-88s and not others. Don't get all picky with me about this because, as we're already seeing, The Ju-88 was a modular shapeshifter, and the Bola was added, modified, or completely taken off depending on whether the variant was dropping bombs, hunting bombers at night, or taking photos. If it was an A-series bomber, it almost certainly had the Bola. It was first introduced on the Ju-88 V4 prototype after earlier tests showed the crew was completely blind to attacks from below and behind. It was the designated station for the ventral air gunner flight engineer. He had to lie flat on his stomach on a padded mat for hours on end, facing backwards, peering out through a trench to man a 7.92mm MG-15, or later a twin MG-81Z or heavy 13mm MG-131. In the heavy fighter or night fighter role, the Bola might be modified to hold two forward-firing 20mm MG-FF cannon. Long-range recon versions kept the ventral gondola and its rear-facing defensive gun. When you're flying deep into enemy territory alone with no escorts, you absolutely wanted someone watching your belly. High-speed fighter and bomber versions omitted the Bola as it was a massive source of parasite drag. It was also a source of crew discomfort. The conditions for the bottom gunner in the Bola were brutal. It was noted that a human couldn't physically stay down in that prone position for more than an hour at a time due to muscle cramping. Junkers actually had to install a tiny folding rest seat up in the main cockpit, so the lower gunner could crawl up out of the tub to sit down and rest his back during long transit flights. We should also talk about dive bombing again. The Ju-88 was always a reluctant dive bomber. It wasn't designed as such in the beginning, but had the ability added on. Although the 88 could definitely perform the role, as I said earlier, it was pretty rough on the airframes and the crews. And although it wasn't dropped in one dramatic official decree, it kinda eroded away in 1943, due to a mix of extreme airframe fatigue, changing battlefield realities, and a massive tactical pivot. By mid-1943, the Luftwaffe realized that forcing a twin-engine medium bomber into 70-degree near-vertical dives was a long-term structural death sentence. The physical toll on the aircraft was immense, and the attrition rates from structural failures or pilots backing out was becoming unsustainable. So the RLM and Luftwaffe High Command officially changed the tactical doctrine for the Ju-88. Pilots were ordered to stop performing steep vertical dives, and instead they moved to the more shallow 45-degree gliding dive. Frontline maintenance units were allowed to remove the dive brakes from existing machines, and factory lines stopped installing them altogether on later production blocks. By the end of 1943, Germany was completely losing the strategic initiative. They were no longer invading countries or conducting massive offensive blitzkrieg strikes where precision tactical dive bombing was needed to clear a path for panzers. They were now on the defensive, desperately trying to stop the RAF and US AAF bomber fleets from leveling German cities. Because of this, production priority for the Ju-88 shifted entirely away from the A-series bomber and focused squarely on other, more defensive types. Dive brakes were not needed at all, and a smoothed-out airframe for pure aerodynamic speed was needed to hunt Lancasters in the dark. So the Ju-88C, heavy fighter or night fighter, was developed as small batches of converted bomber airframes. Those had a metal nose swapped in from the glazed nose of the bomber. These were armed with two 151 MG cannon and two MG-17 machine guns housed in that solid nose. Between 3,200 and 3,500 were built. On the other hand, the Ju-88G was a dedicated night fighter with about 2,900 built. It was designed to be the late war savior of the German night fighter force and was arguably the most effective German night fighter of them all. It had extended wingtips and rectangular tail surfaces and was powered by two BMW 801D engines and armed with four 20mm MG 151-20 cannon in a ventral pod. Two more cannon were usually placed in the dorsal position, firing diagonally upward and forward, and known as Schräge Musik, which means slanted music or jazz. It was extremely effective against British bombers because they lacked ventral guns. Remember how I said that the Ju88 looked like it was powered by radials when it was not? Well, the Ju88R night fighter actually was powered by BMW 801 air-cooled radials instead of the usual liquid-cooled UMOs. Only about 50 were built. This number was kept intentionally low because those prized BMW radials were desperately needed for the Focke-Wulf FW190 assembly lines. The D variant was a long-range photo recon with about 1,450 built. They were some of the eyes of the Luftwaffe. They were built parallel to the A-series bombers but stuffed with cameras. These operated heavily on all fronts, especially over the vast spaces of the Eastern Front. So the 88 was originally supposed to be a Schnell bomber, or fast bomber, that used speed as a defensive tool. Well, fighter performance had caught up. Also, we know that adding other defensive armament had added drag and eroded this basic tool. The Ju88S was the attempt to put that tool back in the tool belt. To do that, designers firstly smoothed over every bit of drag that they could find. They completely tore away the multifaceted, drag-heavy beetle eye glazed nose. In its place, they bolted on a perfectly smooth, hemispherical plexiglass nose cap, very similar to the solid nose of the fighter variants. The on-again, off-again Bola belly tub was completely omitted from production. The bottom of the cockpit was manufactured perfectly flat and flush, eliminating a source of parasite drag. All external underwing bomb racks and dive racks were discarded. The S-series carried its entire bomb load completely enclosed within the internal fuselage bomb bays. To go faster, the plane had to be lighter, and so was put on a crash diet, which meant sacrificing defensive security. They eliminated the fourth crew member, the ventral gunner. All forward-firing defensive machine guns were removed. The only defensive weapon left on the entire airplane was a single 13mm MG 131 machine gun mounted in the rear cockpit position. Also, all but the most absolutely vital heavy steel armor plating protecting the crew and engines was removed. Only so much could be done with cleaning up with weight and drag. The 88S needed more power. There were three evolutions of S engines. The S1 was powered by 1,700 horsepower BMW 801 G2 engines. The S2 added exhaust-driven turbo superchargers for better high-altitude performance, which bumped the horsepower up to 1,810 horsepower. Finally, the S3 was fitted with the highly advanced 12-cylinder liquid-cooled Junkers UMO 213A engines with specially designed exhausts to face backward, providing an extra 340 pounds of pure jet-style thrust. These engines produced a staggering 2,300 horsepower under emergency combat boost. Lastly, to ensure that they could escape Allied interceptors at high altitude, both the S1 and S3 variants were equipped with a GM1 nitrous oxide injection system. When the pilot hit the switch, nitrous oxide was injected directly into the engine superchargers. The nitrous acted as an artificial oxygen supplier in the thin high-altitude air, cooling the intake charge and forcing the engines to explode with a massive surge of temporary horsepower, pushing the S1 to 379 miles per hour and the S3 to 382 miles per hour, about 100 miles per hour faster than their conventional bomber sisters. To get greater detail on these kind of engine upgrades, check out my Quest for Power series. All of this tinkering sounds amazing, but it's kind of bittersweet. It arrived far too late for one thing. By the time the S-Series entered production in late 1943 and early 1944, Germany was on the back foot. The few S-1s that saw action were used briefly as high-speed pathfinders during Operation Steinbock, which was known as the Baby Blitz against Britain. But by late 1944, the superior S-3s were largely grounded on the tarmac. They were pristine and incredibly fast, but the Luftwaffe's dwindling fuel supply was being husbanded for fighter defense. The other thing was that even after all that tinkering, the 88S was only able to hit 382 miles per hour, while the British Schnellbomber, the Mosquito, could go 415 miles per hour while carrying double the bomb load. The Ju88T high-speed photo recon was the reconnaissance sibling to the high-speed S-Series. Like the S, it stripped away the bola and defensive armor to let pure speed protect the crew over enemy territory. About 120 were built. You gotta see this one. The Ju88H long-range Atlantic recon actually looks kind of funny. They literally cut open a Ju88D fuselage and inserted extra fuselage sections to stretch the body, packing it with massive internal fuel tanks so that it could fly grueling, long-range maritime patrols over the Atlantic Ocean to find Allied convoys. I'll post some images and you'll see just how weirdly stretched they were. Only about 20 to 30 of them were built. The last variant I'm going to tell you about is the Ju88B. Only about 10 were built, but it had a really interesting look that will pop up again later. It featured an alternative design for the cockpit, giving the aircraft a single, fully glazed, stepless nose with a bullet-shaped canopy that reached all the way around, over the pilot's position, and met the rear fuselage behind the dorsal gunner's position. The lower canopy was bulged downwards, giving the fuselage a tadpole look in order to provide a place for the rear-firing ventral gun. In one of the most serious cases of on-again, off-again I have ever seen during this podcast, the design was first rejected in 1936, but limited development work was authorized late in 1939 into 1940. 3 prototypes of this design were constructed: a bomber, a reconnaissance prototype, and a Zerstorer. All of this work did not produce enough of an improvement in performance to justify delaying production of the main A-series of the Ju88. 10 pre-production Bs could squeeze out about 10 to 15 miles per hour more, so they did not enter production. So the on-again, off-again thing ended with off, right? Not really. It was on again when the 88B became the basis of the Ju188 and 288. Yes, kids, there will be attempts to replace the venerable 88. I have a couple of oddities to tell you about before we move on. During the Battle of Britain, the Luftwaffe ran into a massive problem: British barrage balloons. These massive, helium-filled aerostats were anchored by heavy, high-tensile steel cables that could easily slice off a bomber's wing if it hit one at low altitude. To solve this, German engineers experimented with a massive triangular steel framework that wrapped around the front of the aircraft. The concept was sometimes called a paravane, which borrowed the naval term for mine-sweeping cutting cables. The Germans officially referred to the cutting mechanism at the wingtips as the Coutonnes, cutting nose. It featured a massive heavy steel fender that extended from the nose out to the wingtips. Take a look on Patreon, cause a picture is worth 1,000 words. The idea was that the fender would catch a balloon cable and guide it out to the wingtips, where a specialized explosive or mechanical blade would chop it in two. So what was the result? I think you smart warbirders can already figure it out. The heavy framework added roughly 700 pounds of dead weight to the nose. To keep the now nose-heavy plane from flipping forward, they had to add a 130-pound counterweight onto the tail, which added more weight. Having all that hanging out there added drag, which knocked at least 20 miles per hour off the top speed, ruined handling, and forced the Luftwaffe to reduce the crew size to 3 and cut down the bomb load just to keep it airborne. It didn't take long for them to realize that the cure was worse than the disease, and so the experiment was scrapped. One thing I've noticed about successful warbirds of any nation, if the plane is good, they will try to put bigger guns in it. Just like the de Havilland Mosquito fighter bomber Mark 18 Tessie and the North American B-25G and H Mitchell. Of course, the Luftwaffe did it too, strapping a pair of 37mm cannon on a Stuka. The Ju88P series took it to the extreme. Designed as a heavy bomber-destroyer or anti-tank platform for the Eastern Front, they bolted massive anti-tank artillery pieces onto an enormous and sometimes unaerodynamic ventral pod under the fuselage. The P-1 version was armed with a massive 7.5 centimeter board cannon, which was a modified semi-automatic version of the PaK-40 anti-tank gun. The recoil was so immense that it violently put staggering structural stresses on the airframe, and only about 40 of those were built. The P2 and P3 versions swapped the overly aggressive 7.5 centimeter monster for twin 3.7 centimeter cannon. These had a higher muzzle velocity and were much more practical for hunting Soviet T-34 tanks. Trying to find the Goldilocks spot for just the right size of cannon, the Ju88 P4 replaced the previous setups with a single 50mm board cannon, BK-5. This was adapted from the 5cm gun used on the Panzer III. Because the 50mm cannon was physically smaller than the 75mm gun, Junkers was able to design a much tighter, more streamlined underbelly pod. This greatly reduced aerodynamic drag, giving the pilots a fighting chance to fly the aircraft without fighting severe handling penalties. Approximately 32 P4s were built or converted starting in late 1943 to early 1944. They saw active combat on the Eastern Front, most notably with Wurzkommando für Panzerbekämpfung, which was a specialized tank-busting squadron. While they were still vulnerable to Soviet fighters if caught without an escort, the P-4 crews proved highly effective at knocking out armored vehicles and logistics trains. The 50mm shell possessed more than enough kinetic energy to punch cleanly through the thinner tops and side armor of Soviet medium and heavy tanks. They may be fun to talk about, but the P-series was overall not very successful. Their low speeds made them easy targets for ground fire, and they were too slow for use against heavy bombers. Only between 60 to 70 units of all 4 versions were made or converted. Lastly, I'm going to tease you a little bit. Ju-88s were also used for the parasite flying bomb program known as the Mistel, which means mistletoe, which sounds misnamed and too festive. Until you know that mistletoe really is a parasitic plant that grows on the branches of trees. If you know that, it does seem a little strange that we're supposed to kiss under it. But to get back to the warbirds, as the war turned against Germany, they began the Mistel experimental program. They took old, wore-out Ju-88 airframes, completely stripped out the cockpit, and replaced the entire nose section with a huge 2-ton shaped charge explosive warhead, designed to punch through capital ships or reinforced concrete bridges. A fighter, usually a Focke-Wulf 190 or Bf 109, was mounted directly on top of the bomber using a specialized strut framework. The fighter pilot would fly the entire composite rig to the target, lock the Ju-88 onto a diving trajectory, and hit a quick release button to detach and fly away while the pilotless, explosive-laden Ju-88 guided itself onto the target. I'm not going to say any more about it because I want to do a series on the history of Mistral-type aircraft from all nations and up to today, because designers are still strapping airplanes onto other airplanes for a variety of reasons. Well, I'm going to wrap up here. Yes, I know there's lots more. I always suspected that this one would be a multi-parter. But my research yesterday made that a certainty. Usually my survivor section is pretty easy, going something like this. The airplane was dredged out of a lake, transferred to somewhere, where they spent years fixing it up, and now it flies with the Flying Bulls, or you can see it at the Chipping Under Rootshire Aerodrome RAF Museum. That's a made-up place, by the way. The two surviving Ju88s have amazing stories that are going to get their own episode, along with any leftover material, and of course, there are the replacements for the Ju88 that you're going to want to know about. There may even be a bonus episode for Patreon supporters. And thank you to Patreon supporters. You guys keep me getting up at 5 a.m. to make this show. You can all check out the photos of what we've been talking about on the Patreon page. Those are available to all. Why not join Patreon? There's a free option. And if you can't, why not leave me a good review? Until next time.